Hello everyone. So, let us continue our discussion. We are in week 5 and this is our 5th lecture. Today we plan to solve some examples, right. So, example 1. The problem statement says epsilon xx is equal to p times y, epsilon yy is equal to p times x, epsilon zz is equal to 2p times x plus y. Then gamma xy is equal to p times x plus y, gamma yz is equal to twice p times z, and gamma xz is equal to twice p times z. We are supposed to check the compatibility of the given strain field. Okay. So, if you recall, what are the compatibility conditions we derived yesterday? Altogether 6 compatibility conditions are there. The first condition is between epsilon xx, epsilon yy and gamma xy. Similarly, we have 2 more. The second one is between epsilon yy and epsilon zz with gamma yz. Last one is between epsilon zz and epsilon xx with gamma xz. So, these are the first 3 and then we have 3 more, and the remaining 3 are so that is the first one involving, you see, on the left hand side we have gamma xy, yz, zx, and on the right hand side we have yz. Similarly, we have 2 more equations. And the last one is okay. So, what we have to do? We have to evaluate all 6. We have to evaluate and check whether all these 6 conditions are satisfied. So, let us start with first one. So, we have epsilon xx as p of p times y. So, if we differentiate twice with respect to y, this is 0. Similarly, we have epsilon yy, that if we differentiate twice with respect to x, it is also 0. We have to check gamma xy, which is here. So, twice if we differentiate gamma xy with respect to x and y, and then obviously what we have is say first we differentiate with respect to y, we will be left with p only, and then if we differentiate this quantity with x, so it is 0. It means the first condition is satisfied. Now, let us try other conditions. So, first condition satisfied. So, let us put a green mark. So, this condition is satisfied. Let us try with this one. Again, epsilon yy, if we differentiate twice with respect to z, this is 0. Similarly, if we consider epsilon zz, and that if we differentiate with respect to y twice, so what we have is, you can see, first we differentiate with respect to y once, so we will have 2p, and the moment we differentiate twice, we will have 0. Then on the right hand side, we have gamma yz. So, gamma yz is here. Obviously, it is a function of z. So, if we differentiate with respect to y and z, again it will be 0, right. So, this quantity is 0. That means the second equation is also satisfied. So, this is satisfied. Let us quickly check third equation. For third equation, on the left hand side we have epsilon zz, which is differentiated with respect to x. So, let us see what we get. So, epsilon zz with respect to x, and the expression is here. Obviously, if we differentiate twice with respect to x, it is 0. Now, next one is epsilon xx, which is here. So, not a function of z. So, if we differentiate twice with respect to z, obviously this will be 0. On the right hand side, we have gamma xz. Gamma xz is here, and that we have to differentiate with respect to x, with respect to z. So, first if we differentiate with respect to z, we have 2p, and that we differentiate with respect to x, we will get 0. So, the third condition is also satisfied. Now, we have to check the remaining 3. Let us do it one by one. Okay. So, what we have here, gamma yz differentiated with respect to x. So, gamma yz is here. Gamma yz is not a function of x. So, if we differentiate, obviously this will be 0. Next is gamma xz. Xz is here. That if we differentiate with respect to y, obviously it is 0, because gamma xz is not a function of y. Last quantity, gamma xy, which is here, that we have to differentiate with respect to z. Again, it is not a function of z. So, what we get, gamma xy differentiated with respect to z is 0. That means, the left hand side of this equation here, fourth equation, it is 0, right. So, let us check whether the right hand side is also 0 or not. So, what we have here, epsilon xx and expression of, epsilon zz. So, expression is here. So, what we have to do, twice of epsilon zz differentiated with respect to x, with respect to y. Okay. So, what we have, 2 times, then so this is equal to 2 times dou x then within third bracket, if we open this bracket and differentiate with respect to y, we have twice p. So, this is equal to 0. So, that means fourth equation was also satisfied. So, this one is satisfied. Let us check the other two. For that, we have the first term gamma xz with respect to y. So, gamma xz is here, it is not a function of y. So, this is 0. Next one is gamma xy with respect to z. Gamma xy is here, it is not a function of z. So, this is 0. Last term gamma yz, yz is here, and that we have to differentiate with respect to x. Again, it is not a function of x, and therefore, it is 0. So, the left hand side of the equation is 0. Now, to check the right hand side, there we have to differentiate epsilon xx with respect to y and z, right. So, we have now expression of epsilon xx is here. So, what we do, if we differentiate with respect to say y first, and then we have p, and then again if we differentiate with respect to z, we have 0. That means fifth equation is also satisfied. So, this equation is satisfied. Last equation we have to check. For that, again let us do one by one. So, the first term gamma xy with respect to z, right. So, gamma xy is here, it is not a function of z. So, if we differentiate with respect to z, it is 0. Second term yz, and that we have to differentiate with respect to x. So, yz is here, it is not a function of x. So, this quantity is 0. Last term xz, and we have to differentiate with respect to y. Xz is here, it is again not a function of y. So, we have 0. Now, on the right hand side, we have yy, and that we have to differentiate with respect to x and z. So, we have yy with respect to x and z. So, what is the expression of yy? It is here, sorry, right. So, it is p of x, that if we differentiate with respect to x, we get p, and then second time if we differentiate with respect to z, we get 0, which means the last equation is also satisfied. That means it proves the given strain field here, it satisfies the compatibility condition, right. Okay. So, it is a valid strain field. Okay. So, that shows how we can check with the compatibility conditions whether it is satisfied or not. Let us take a similar example. Now, for this case, we have epsilon xx is equal to 5 plus x square plus y square plus x to the power 4 plus y to the power 4. Then epsilon yy is equal to 6 plus 3x square plus 3y square plus x to the power 4 plus y to the power 4. Then gamma xy is equal to, we have 10 plus 4 xy times we have x square plus y square plus 2, and given that epsilon zz is equal to gamma yz is equal to gamma xz is equal to 0. Okay. So, that is the given components of the strain, and then we are supposed to check whether the compatibility conditions are satisfied or not. So, again we have all these conditions, but again here we have the strain along z direction, they are 0. So, obviously, if you recall, we have a plane strain. Okay, so let us try the first one. So, we have epsilon xx, epsilon yy and gamma xy. So, the condition is okay. So, the first term here is twice we differentiate epsilon yy with respect to x. If we do that, so we have 0 here from the first term plus 6x plus 0 plus 4x cube. Then if we differentiate once more, what we have is 6 plus 12 x square, right. So, that is the first term. Okay. So, left hand side we have the first term is 6 plus 12 x square. Let us check the second term here. So, we have epsilon xx this time differentiated twice with respect to y. So, let us try. So, what we have is 2 plus 12 y square, right. Okay. So, we have the left hand side ready. So, plus 2 plus 12 y square. So, this is equal to 8 plus 12 within bracket x square plus y square, right. Let us try right hand side, and for that we have to differentiate gamma xy, which is here. First, let us differentiate with respect to y, and then we will do with respect to x. So, this term let us simplify, 10 plus 4 x cube y plus 4 x y cube plus 8 x y. Okay. So, if we differentiate with respect to x, then first term is 0, then we have 4 x cube, then we have plus 12 x y square plus we have 8 x. Then second time if we differentiate, what we have is 12 x square plus 12 y square plus 8. So, what we have is LHS is equal to RHS. That means, first condition is satisfied, right. So, what I suggest you can actually repeat the exercise and verify the other conditions. Okay. It is a similar problem. Actually, this plane strain condition will simplify a lot of expression, because this strains along z directions, they are all 0. So, it is very easy to cross verify. At least what we have established, that first condition is satisfied, you further verify what about the other condition. So, I leave it as a home task. Please check yourself following the same steps that we have taken for previous problem. Okay. Our last example, example 3, is where we are given the strain field epsilon ij is equal to P times, we have 1 0 0, then 0 0 minus 4, and then 0 minus 4 3 into 10 to the power minus 4. Find out principal strains. Now, for that again we have already derived those expressions. If you recall, what we have to do, we have to go for the eigenvalue problem, right? And characteristic equation is a cubic equation that involves 3 strain invariants . So, we can evaluate 3 strain invariants. I1 is equal to, we have the leading diagonals. So, P into 10 to the power minus 4, then 1 plus 0 plus 3, right. So, we have 4 P into 10 to the power minus 4. I2, we have 1 0 0, then 0 times P into 10 to the power minus 4, plus we have 0 minus 4 3 P times 10 to the power minus 4, plus we have 1 0 0 3 P into 10 to the power minus 4. So, you can simplify P into 10 to the power minus 4, we have 0 first term, plus then again we have minus of 16 and then plus 3. So, effectively I2 is minus 13 P into 10 to the power minus 4. And I3, if you solve, you have to take the determinant of this matrix. So, we have P into 10 to the power minus 4. Now, that if you put back in this equation and solve for epsilon 1, 2, 3, again it is very simple. We have already solved similar example for 3D stress. You can get the values of the principal strain. And let me give you those values of principal strain. So, these are minus 2.77, then 1 and then 5.77. So, these are the principal strains, obviously multiplied by P into 10 to the power minus 4. Right. What about direction cosines? For that, let me give you direction cosines for all of them. So, 0, then minus 0.82 and then minus 0.60, then 1 0 0, then 0 minus 6, sorry 0 minus 0.6, and then the last value is 0.82. So, these are the directions, principal, principal directions. So, the first column corresponds to first one here, and then this one is for second one, which is 1, and the third one is 5.77. Okay. For them we have nx, ny and nz. Solution is again the same. So, you start with this, say, first one that you have to put back in the original expression. So, that expression is not here. You can easily refer our old class notes, and then there you have to consider two equations, and the third equation is the properties of direction cosines, which is nx square plus ny square plus nz square equal to 1. And with that, if you solve for nx, ny and z, you will get direction cosines of the principal planes, and you will get these three sets of values of nx, ny and z. And if you plot this, you can see it here. So, we have three principal values. One is here, recall it was minus 2.77. Then second one is here. So, this is epsilon 3, and then you have 1.0, this is epsilon 2, and the maximum one is 5.77, epsilon 1. Again, you can identify the maximum value of shear strain, which is here. So, it is close to 4.5, and obviously, we have a factor of p times 10 to the power minus 4. So, that will be there, but the point to be noted here is that corresponding to this maximum shear strain, we have some value. Again, this is roughly 1.5 is basically the associated normal strain, okay, at this point. And this is the radius of the circle. What is the radius of the circle? If you recall, epsilon 1 minus epsilon 3 divided by 2. So, that is the radius of the circle, right. So, we completely solve the problem, and for that we also have the Mohr circle drawn. And again, in this case also you can try with any point inside the pi plane, and then from there you can read the respective strains, and we can also find out the directions, right. So, that completes the exercise. I hope you could follow. The intermediate steps, this time I skipped simply because we already explained that even with the help of a MATLAB code in case of 3D stress analysis. So, you follow all those intermediate steps, and obviously, if you have any doubt or any question, please let us know, and then we will definitely clear your doubts. We can also discuss this problem in our open sessions. Thank you very much.